Good afternoon, everyone. I would like to present our work on the in vitro evaluation of the performance of Populus tremula clones in two different media, the ACM and the MS media, in the establishment and also in the multiplication phases. But before I start, I would like to just give a pre-note for better understanding of the topic. I will start by asking my distinguished audience a rhetorical question. Have you ever wondered how the Earth would be if plants could no longer resist the harsh environmental conditions and thus die off? I believe your reply will be as mine, is better imagined than experienced. Plants are being faced with a lot of stresses, both combined stresses and stresses due to climate change and other factors majorly caused by humans. And the sad truth is that it only gets worse. From the solid future predictions of what the future looks like, the global warming is expected to increase by 20%. Temperature is also expected to increase by 1.54%. And also, rainfall is expected to reduce by minus 30% in spring and summer. These parameters being shown here will surely lead to the extinction of species. Populus tremula, which is the plant I'm working with, just like also all other plant species, is being threatened with the risk of all this climate change, and thus there is need for conservation. Populus tremula is found in Europe and also in parts of Asia. In Spain, it is found in the northern part of Spain and also in the north-central part of Spain. Populus tremula population in Spain is even more threatened because Spain is the southern limit of the Euro-Siberian species. So why in vitro? Why do we decide to work on the in vitro conservation of Populus tremula? Seed conservation is usually the most preferred form of conservation that we all know, but in Populus tremula, seed conservation is short-lived. This is because the seed are recalcitrant, that is, they cannot be preserved for a long time under in vitro conditions. And also, in vitro conservation of Populus tremula is very more preferred because you don't have to talk about so much space, it needs minimum space, it provides disease-free plants, and also the rootings are very easy, more than the stem cuttings. As we can see, this is a picture of how the in vitro culture of Populus tremula looks like. If you look at the base, you can see the rooting system, how well rooted the plant is. And also, this is the seeds of Populus tremula. Now, our objectives of the study was to compare the two different media. Having already established the fact that in vitro is the best fit for the conservation of Populus tremula, we wanted to know which of the media, the MS or the ACM media, is best suited for the conservation of this plant. And also wanted to check the different clones and see how they respond to these different media. Now, to what end? Why do we want to check this? This is because we want to generate a great number of clones in the shortest possible time. This information will be of very, very great help to, apart from in conservation, it will be of great help to plantation farmers and also to industries like pharmaceutical industries that would like to extract, that would like to take advantage of the phytochemical properties of the plant. So the most important section that we researchers always want to know, what did we do? In our experiment, we worked with 8 different clones of Populus tremula, and we also worked with 2 different media, which is the MS and the ACM media. The MS and the ACM media were prepared using the standard preparation methods. The MS media was prepared using the methods as described by Murishige and Skog in 1962. And also the ACM media was prepared using the methods by Ahuja in 1982 too. So what we did is that we prepared the media and we also made 1 centimeter each of the explants and we cultured them in the media. We did our sterilization with 70% alcohol, and we worked with the flow chamber, because in the sterilization and the culturing process, we do it in the flow chamber to reduce the amount of contamination for the experiment. After that, we grew the plant, we cultured the plant in the growing chamber. The growing chamber looks like this, just as this image here is showing. So the growing chamber provides the plants with all the necessary conditions it needs to grow, the right amount of light, the right amount of temperature. Also, the parameters we considered in our experiments were the explant height, the number of stems, the rosette, and also the vigor, the contamination, of course, and the callus, which is one of the most important also. This experiment is still ongoing, as currently we are in the proliferation and the multiplication phase of the experiment, but we were able to do a descriptive analysis of with the data we have gotten from the past 3 months to at least give us a view of what we are doing so far. Interestingly, we found out that the clone 1PT and the clone 19PT, they did very excellently well in the ACM media, while the clone 7PT and the clone 20 and 21PT did very well in the MS media. Also interesting to know is the callus formation. We made a percentage composition of our callus formation, and we discovered that the lowest callus formation were formed in the ACM media. As we can see here, in the 7PT, when the callus formation for the ACM in the first month was 0%, for the MS it was 40%. And here also, when it was 0%, here is 10%. This information is of great interest to people that would like to do further research in genetic engineering and also in plant biotechnology, because callus formation is a very right time to try to, because callus are undifferentiated cells, so it's a very right time to try, depending on your interest, to try to engineer the plant you want to work with. So this is just like a photo gallery of the experiment so far. The interesting part of this image I would just like to point out are this, which I've already explained. This is how the growing chamber looks like. And also, if you look at the down of this image, we could see the callus formation here. The whitish substances, that's the callus formation. And also here, this is the contamination. In our experiment, we recorded 14% contamination, which is very good, considering, which is very good because it's very low. But this image is very interesting because if you look closely at the explant, we could see that it shows a very good vigor. The plants are very green, it has many leaves, it's very good. It could be that the interaction, the fungi and the plant interaction is very good, and it could be that it's not so beneficial, but further research can tell us for sure. Also, in conclusion, we were able to establish that there is a strong interaction between the Populus tremula and the different media we worked on. And also, I think further researches can also be done to be able to check different other parameters, as I said, like the contamination and so many other things. I would like to conclude by thanking personally as an individual. I would like to thank Aitor for his help during the project, the president of IFSA, Palencia. It is always great to be an IFSA member, and even more better when you're an IFSA Palencia member. I'm a proud one. And also, I would like to thank Carlos, my mentor, who is also present here, even in his tight schedule, for his moral encouragement and support. Thank you.